Let's begin. Today's November 5th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 6, 10, 16, 21, and 22. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally, criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine will be comparing it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B takes a look at our middle digit, the square digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C takes a look at our 3-digit solution, and the Turing Machine will let us know how many of those digits are 4. Are there no 4s? Is there a single 4? Perhaps 2, maybe even all 3 are 4. Criteria card D, again, takes a look at our 3-digit solution, but this time it'll let us know a little bit about the ratio of even to odds. Should there be more even than odds, or should there be less even than odds? Criteria card E, again, takes a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 2 cases. One where there is a pair, as in the example 131, or alternatively, there is no pair, but there are a couple of scenarios. One where all the digits are distinct, as in the example 134, or all the digits are the same, as in the example 222. And finally, criteria card F will take a look at our digits from triangle to square to circle, and will let us know a little bit about the ordering of the digits. Could they appear in an ascending order, meaning that they're increasing, as in the example 135, or could they be in a descending order, as in the example 421, or potentially they could have no order. So let's take a look at the example of 231. Notice that it goes from 2 to 3, which is increasing, and then 3 to 1, decreasing. Of course, you could also have a code that's decreasing and then increasing, but it's really that shift from increasing to decreasing or vice versa that's one way to define a 3-digit code as having no order. There are other cases where we've seen in previous puzzles where if you have consecutive equal digits that also exhibit no order. So the fact that they're consecutive and equal, if you go from left to right, there's no change between those equal digits. So that again is another way you can describe a 3-digit code as having no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice for square. I did pick an odd 1, but because the Turing Machine does not agree with that, it's letting us know that actually square should be an equal digit. Sorry, an even digit. All right, so let's go ahead and type that up in our notes in section B. And again, we'll say that square is an even digit. And since it is even, that means we can go ahead and cross out all of the odds in square. So we can cross out 1, 3, and 5. Okay, I think the next thing I'd like to test is criteria card D. Okay, so the Turing Machine approves of my choice in 314. Remember that criteria card D is letting us know a little bit about the ratio of even to odds. In my proposal, I've got 2 odds to a single even, and the Turing machine agrees with that. So yes, it's true that there should be less even than odds. So let's go ahead and type that up in our notes in section D. And we'll say that even is less than odd. And remember from criteria card B, we already established square to be even. So that means if we do have a majority of odds, that means that triangle and circle must be odd. So let's go ahead and cross out the evens in triangle and circle. And so it looks like our solution is going to be odd, even, odd. Okay, now we also have criteria card E that'll let us know if we have a pair. Perhaps those odd digits may be paired up. Let's take a look. Well, let's see. Actually, I wonder maybe we can deduce criteria card D. So as I mentioned at the top of the video, you could have consecutive equal digits in order to have no order. Well, that can't be the case here, right? Because we are going from odd to even to odd. But there is another case, remember, where it shifts. Now, what would happen if you had a pair of digits, for example, say 3 and 3, then it would go, say, from 3 to 2 or 4, and then back to 3. So that would mean that if you had a pair of digits, it would have no order. And so that would make this criteria card irrelevant. Now, let's see, I'm trying to think of, I think regardless if we, I always have the debate whether, if I've already started the puzzle, I've already identified certain digits as being odd or even, and then can I make the same conclusions as if I had never started? And I think if you ever had a pair, regardless if there were consecutive, right, equal digits, or if they are separated by that middle digit, that would mean that you would have, I believe, no order. So regardless if you have a pair that are consecutive or separated by that square digit, if it's a pair, that would mean that it's no order, making this card irrelevant. So I think this is bold because I don't think I've ever made this conclusion before, but I'm going to go out on a limb and state that the criteria card D, I'm going to deduce that there's no pairs. So let me go ahead and type that up in E, and I'm going to say I'm going to deduce that the solution has no pairs. Okay, so again, this is the first time to my recollection, that I've made this sort of deduction. So let's see what happens. So again, I'm going to deduce that there are no pairs, meaning that triangle and circle are distinct odd digits. Okay, well, that's one last thing to have to consider. At this point, that criteria card C, the number of 4s, well, there's only one even, so it's either there or not, and so therefore we have our even. And we also have criteria card A comparing triangle to the number 3, and I don't think there's ever a good choice. Since I have 3, it's right in the middle. It could be. And the other thing to notice is that there's no mention of circle in any of our criteria cards, at least not directly. So that typically means that circle is going to be forced into a particular value. And more than likely, it comes down to basically criteria card F, depending on the ordering. So let's see. Let's go ahead. Well, let's see. Yeah. Is it worth it to test A? Yeah, I kind of would lean towards A just because we may have to test it again. So even though I did pick a 3, let's go ahead and test criteria card A. Okay, wow, very fortunate. We got it right exactly at 3. So let's go ahead and type that up in our notes. And we'll say that the triangle value is equal to 3. And so let's go ahead and cross out the 1 and 5 in triangle. And also, since we know, well, based on the deduction that there's no pairs, let's go ahead and cross out the 3 in circle. Since, again, based on that deduction, both odds, triangle and circle, must be distinct. Okay, well, that does it for this round. We've already completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So again, we did not test criteria card C, identifying, I guess now, our square digit as being 4 or not. And also we have criteria card F, that'll identify the ordering of our digits. And remember that we do have that deduction in criteria card E, so we should be looking at 1 or 5. So what do our solutions look like? Well, we do have a descending solution in 3, 2, 1. We also have a ascending solution in 3, 4, 5. And then, of course, we've got our 2 distinct no order, and that is 3, 2, 5 and 3, 4, 1. So let's see, is there a way to somehow deduce no order? Or is it just going to be descending? Is there something in our... Well, we sort of established that if you had a pair of digits, that would automatically mean no order. So that's how we came to the deduction that there should be no pairs. Is there something we could say about the ordering? Yeah, I don't see anything. Well, that will be interesting. So we definitely have a 2 or 4 in square. I'm typically, although you can't say 100%, typically the solution always has no order. So I'm going to pick between 3, 2, 5 and 3, 4, 1. And I think I'm going to go with 3, 2, 5. So yeah, let's go ahead and test 3, 2, 5. Okay, So let's see. Yeah, let's go ahead and test criteria card C. I don't know if we do F and we find out there's no order, that really doesn't tell us much. So let's go ahead, and test criteria card C. Okay, so it is not the case, or the Turing machine does not approve of the fact that I don't have a 4. So it's actually letting us know, yeah, there should be a 4. So let's go ahead and type that will deduce the solution has a single 4-digit. Okay, and so let's go ahead and cross out the 2, leaving us with 4. And so at this point, it's either ascending or no order. And again, I just don't see a way to conclude that. So let's go ahead and type or test criteria card F. Okay, so yeah, it approves of the fact that the solution should have no order. So let's go and type that up. So the solution has no order. Okay, and so based on that, it looks like the solution should be 341. Okay, and of course, again, we did deduce the fact that there should be no pair. Okay, well, let's type that up and see if our deduction of E will have paid off. Okay, so 341, just experiencing a little bit of lag time typing that code up. And so there it is. So let's kind of review quickly. Is our first digit triangle 3? It is. We have an even in our square digit. We did deduce that there should be a single 4. There are more odds than evens. We did deduce that there should be no pairs in our odds. And of course, we have no order. Okay, so based on that, that looks like our solution, but let's go verify. 341. So we got 341. Okay, excellent. So how did we do versus a Turing machine? Well, we look back, our puzzle did have, or does have 6 criteria cards, and we only tested 5. We were able to deduce outright criteria card E. So notice that in our first round, we did A, B, D, and then in the second round, we did 2 of the remaining C and F, and we were able to deduce E. So let's go ahead and type that up. And again, that first round was A, B, D. So A was correct, B was incorrect, and E was correct. Just double check. A, B, D. Did I type that in wrong? A, B, D, yes, it should be D. Oh, let me get rid of E first. There we go, A, B, D. Second round, C was incorrect, F was correct, and if you remember, we deduced E. So how do we do? Okay, so we beat the Turing Machine by one question. And I really attribute that to our deduction in criteria card E. So very interesting. Like I said, I think that may have been the first time I've used that particular deduction. So it really paid off. What about you? What order of criteria cards did you choose? And did you notice anything interesting that you'd like to share? Please add those thoughts in the comments section. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so that you don't miss out on any future videos. You'll be notified of the next one. Well, until next time, have a great one.